No, they're not. They never are. I'll just pause. Let me tell you the story about the word. So back to radical functions. Just a review from last year, but really last unit as well. What is the A? Scared me a little bit there. Yep, vertical stretch or compression. What is the B? Last year we called this H. Sometimes we call it C. It doesn't matter. It's just a variable. It doesn't matter what letter we put it with it. It's still going to be A. And the K? I love it. So we're going to start with doing radical graphs of linear functions. So we're going to sketch the line, and then we're going to do root of f of x as its own transformation. That's the difference this time. It's not the base graph, it's a transformation. And then someone's going to remind me to do the domain and range of the two graphs. Okay, so good time to review. How do we graph a line? Y equals mx plus b. What does b stand for? Intercept, so it's going to be at 1. What does m stand for? Slope. Rise over run, slope. So from that point, we're going to count 2 units down and 1 unit over. Remember in grade 10 when that was so hard and now it's so easy? So now what I want to do is the transformation of the square root of f of x. So what this means is we're going to take all the y values and we're going to take the square roots of them. So I'm just going to work from left to right. The first y value I want to look at is 9. Why am I picking 9? Because it's a perfect square. So if I go over to where 9 is right now, instead of being at 9, it's going to be at the square root of 9. What's the square root of 9? So that point is going to drop vertically down to 3. Okay, I didn't move it left or right. I just dropped it down to 3. Because it will be our last graph. 8, I'm not liking. 7, 6, 5, I'm not liking. I'm going to go to 4 as my next point. Why 4? Because it's the next perfect square. So I'm going to go to where 4 is, and I'm going to drop him down to 2. Again, I didn't move that point side to side. I just dropped it vertically down to 2. What's the next point I'm going to pick? 1, square root of 1. Oh, so that stays exactly where it was. I'm going to go to where y is 0, which is the x-intercept. What's the square root of 0? 0, so he's going to stay exactly where he is.
And then we're in the negatives, which we cannot square root.
Can't square root negative, so none of these points are going to exist. No, it's got to be a swoop, because we know that the square root is a swoop. Oh, I'm going to do one note first.
Yeah, note. Write this down, people. These notes are important.
So if the line that you're dealing with has a positive slope, the swoop is going to go towards the right. If the line you graph has a negative slope, fill in the obvious. Swoop is going to go to the left. In a second, I'm going to make everything we just did there like 10 times easier.
But first, use your domain and range.
So domain and range of the line, XER and YER. Domain and range of the swoop. Agree, disagree? How do we know it's exactly a half? Well, let's find out mathematically if it's exactly a half. How do you know?
Because of the 2 points, one's on 1, the other's on...
How do you know it's exactly a half?
Because 2 divided.
5, 6.
Well, this value here is the x-intercept of the line. How do we mathematically, algebraically calculate an x-intercept?
Replace the y with the 0 and then solve for x.
Replace the y for 0 and solve for x. How do I get rid of a plus 1? Divide by -2, x is a half. Range of the swoop?
Y is greater than or equal to 0.
Which makes sense with it being a square root because you can't square root negative numbers. How are we doing so far? A little bit of theory, what we just talked about. If 0 and 1 are in the range of y equals f of x, then the points with these y coordinates will lie on both graphs. What that's saying is if you go where y equals 0 and y equals 1, it's not going to change from one to the other. Why? Well, what's the square root of 0?
0.
And what's the square root of 1? 1. So they're not going to change because they are their own square roots. Are there any other numbers that are their own square roots?
Nope.
Those are that. We call these invariant points. Invariant points. Invariant points.
Yeah, another big word.
What does vary mean? What does it mean to vary something? To change it. So if something is variant, it means it's changing. If it's invariant, it means not changing. That's where it comes from. Wherever y equals 0 and y equals 1 will not change. So I'm going to draw any line on here. There's no particular place I'm putting that. I'm just doing a downward sloping line. Okay, there's no particular reason I drew it where I drew it. And I want you to put your ruler on the x-axis. Put your ruler right on the x-axis. The x-axis is where y equals 0. So wherever that line crosses the x-axis, I want you to put a point. Wherever that line crosses the y-axis, or the x-axis, sorry, put a point. Sorry for the interruption.
If we could please now have the grade 9 students put the last name beginning with the letter G through to the letter M. Picture retakes are being done in the upper level in the gym. If you have not had your picture taken for the school year yet, or you wish to have retakes, please make your way to the upper level in the gym. Thank you.
Now I want you to slide your ruler where y equals 1. Slide your ruler up to where y equals 1. Wherever that line cuts y equal to 1, put a dot. Because mine that I drew is a downward sloping line, is it going to swoop right or swoop left? Bam, we're done. That's it. That's all we need to do. We just need the 2 invariant points. Done.
I wonder how often the interruption machine's going to pop up on this video.
The second point you need to know is where the graph of y of f of x lies below the x-axis, the graph of y equals the square root of f of x will not exist. Why?
Because you cannot square root negative numbers.
So I'm going to draw any line. I'm just doing it in the other direction for fun. Again, there's no particular place I'm putting this line. I'm just putting a line somewhere with a positive slope. So what this property tells me is anything below the x-axis is gone. It won't exist when I take that radical transformation. It's gone. Put your ruler right on the x-axis. Wherever the graph crosses, put a dot. Slide your ruler up to 1. Wherever the graph crosses, put a dot. Swoop to the left or swoop to the right? How do you know? Because it's going up. Bam, done. There's our radical graph. Is that not just a little bit awesome? Just a little bit. So let's combine it. This time I drew the line for you. What I do, because I'm a visual person, is the first thing I do is I cross out everything under the x-axis. You don't need to do that. It's just a visual reminder to me that it's gone on the new graph. Then I go wherever the x-intercept is and I put a dot. And again, you don't need to use your ruler. It just helps me visually figure out what's happening. Then I go up to 1. Wherever the graph is, I put a dot. Then you just need to decide swoop to the left or swoop to the right. Swoop to the left, go through those 2 points, done. There's a radical graph. Like not an ooh, not a ah, not nothing? Like come on, after what we just did last unit, that's so easy.
We're tired.
Write down the domain and range of the radical. That's not normal.
Yeah, it's Friday morning and we're tired.
I'm a little tired too today.
But I'm going to say the domain is greater than or equal. Oh, wait, no, less than or equal to 1/2.
Do we know it's 1/2? How do we know?
Because the points are clearly marked on the graph.
And if we don't have the equation, then there's nothing else we can do but estimate. If we have the equation, you have to find them exactly, and I'll show you some examples in a second. Range?
Y is greater than or equal to 0. Same thing it always is for radical.
That's what exactly I was about to say, is notice that's always going to be for a radical graph. Why?
Because you cannot square root a negative number.
Because I crossed out these points underneath.
How many more times are we going to say today that we can't square root a negative number?
About, how many more examples are left? 1, 2, 3, 4, 5, about 5 more times. Given the linear function below, draw the radical graph, state the domain. Step number 1. Cross out everything under the x-axis. Will not exist. No, you don't have to. I just am visual, so I like it gone. Then what? X-intercept. Y equals 1. Make sure you're not doing x equals 1, although in this case it won't matter. But make sure you're going to y. That's why I like to use the ruler, because it helps me figure out I'm going horizontally. Okay, so step 1, underneath doesn't exist. Step 2, mark the invariant points. Step 3, swoop. Swoop to the left or swoop to the right? Swoop to the right. Domain. We don't know exactly. Do we have the equation? So we can estimate this one. If we had the equation, we'd need to find exact, but this is going to be an estimate. So x is greater than or equal to 0.75, 3/4. I heard 0.8, 0.6. Can we come to a consensus?
I'd say 1/3.
0.6, 0.75. I kind of feel like 0.7 was in the middle of all that. And I'm just going to make a note. This was an estimation because we aren't given the equation. Okay, it's an estimation because we weren't given the equation. Justine, I don't have my phone out. The range?
Range we never need an equation or an estimation or anything for, because it's always going to be y is greater than or equal to 0.
Unless we then did a vertical transformation. But let's not talk about that.
Yeah, that's last unit. This is this unit.
It's like the units have nothing to do with each other.
Except unit 1 and everything else we've done thus far this year with that circle.
That evil circle.
Those rats that and our lives.
So lines are pretty easy. Let's look at quadratics. Sketch your graph of f of x equals x squared minus 4, and then we're going to do the graph of root of f of x. Then we're going to compare the domain and range. So you could go back and do this with transformations, but I wouldn't because we had a method last year to do quadratics, so I would do it that way. What are the 3 pieces of information we need to draw a quadratic? Vertex, direction, and width. Again, if you'd rather draw the base graph than do the transformations, you can do it that way. What's the vertex of the sky?
0, -4.
What's the direction? How do you know?
It's positive x.
And what is a negative in terms of transformations? A vertical reflection. That's why it was flipping last year. The width. Okay, so vertex first, 0, 4. Over 1, up 1. Over 1, up 3. Over 1, up 5. We're going to do the same steps we did with lines. Anything under the x-axis ceases to exist, so this whole section will be gone. Okay. Anything under the x-axis will cease to exist. Okay, look at where the x-intercepts are, mark them as points. Go up to where y equals 1, mark those as points. Well, now what? Because I got points on each side. Yeah, well, if I look at the left side, is it going to swoop to the left or swoop to the right? It's going to swoop to the left. What about on the right side? Swoop to the right. We get a double swoop. Ooh, ah. He's here. I can't ask him to be happy at the same time. Domain and range of the parabola.
Why is it x ER?
Because the parabola goes on forever, left and right. This is of the parabola. Well, the parabola still has its middle. This is just of the original graph. Now I'm going to do of the radical graph.
Do you always have to do the original graph?
Depends what the question asks. This one says compare of the 2 graphs. Okay, domain of the radical graph. What am I going to do when I got 2 swoops here? Just do them separately. So if I just had this left swoop first, how would I write the domain? X is less than or equal to. Do we know it's -2? Can we say for sure it's -2? Could we just confirm it algebraically to make me happy?
We don't want to do more work than we have to on a Friday morning.
And if I just had the right swoop, how would I do the right swoop? X is greater than or equal to. Do we know it's 2? For sure it's 2? And then I'm going to put this little symbol in between.
You?
So what the heck is this guy? Well,
Letter U.
he's called Union, not onion, as somebody thought last year. Union. Union with a U. What it means mathematically is and. So it's saying the domain is the values that are less than -2 and the values that are greater than +2. But this is universal. And is an English symbol. U. Not onion.
But the X symbol
Union.
is universal.
U. Range, it doesn't matter if we do the left and the right because they're going to be the same. The lowest point is still 0. Highest point is still infinity. So the range is going to be y is greater than 0 because
You can't square root a negative.
this is the only little tricky part. Does this make sense in your head?
Yes. Yes. Domain. X is less than or equal to 2. Onion. X is less than or equal to 2.
Another parabola because they're fun. Vertex. Direction. Width.
Sorry for the interruption. If we could please now have our grade 9 students with the last name beginning with the letter N through to the letter Z that need to have picture retakes or have not had their pictures taken yet for the school year, please make your way to the upper level in the gym. And of course, if there's any other grade 9 students that have not yet had a chance to do so, you can make your way there as well. Thank you.
Why is it so skinny?
Because it's compressed. Stretch.
Vertical stretch. So again, you could have graphed this by taking the base graph of x squared and then doing the vertical reflection and then doing the vertical stretch and then doing the vertical translation, but use this one because it's way easier. Just gives it all to us at one point.
Yep. Figure out what we have to draw without even having to draw anything.
Everything under the x-axis goes away, so the left and right sides are going to be gone.
Because you can't square root a negative.
The middle part, however, is a little bit different. So let's start with what we know. Go to the x-intercepts, mark them. John. Go to where y equals to 1, mark them. The problem this time, it's not swooping out because this is going towards the y-axis, and this isn't going to swoop out because it's going towards the y-axis. So I got to figure out what's happening in the middle. Well, the easiest is to take the vertex. And don't forget what this transformation is the root of all y values. So what is the square root of 9? So this point's going to drop all the way down to 3. So with a down parabola, you get this little hill.
It's a little mini parabola.
And so we just found the middle point by taking the square root of 9, which happened to be 3. So if you have an up parabola, you'll end up with double swoop. If you have a down parabola, you'll end up with a little hill.
Or a mini parabola.
Or a little mini parabola that doesn't go on forever.
And, well, n doesn't cross the x-axis because you can't square root a negative number.
And how high the hill is will just depend on what the square root of the vertex is. So it comes from the square root of the y value of the vertex.
It's not really what I was expecting because as a parabola is y equals x squared, I was expecting the square root graph of that to be a line.
But then you got the 2, you got the 9 in there, you got a whole bunch of stuff going on in there. Domain. Oh, we don't know these exactly, do we? What do we need to do? What do we need to do?
Use the equation.
We we have to find the x-intercepts algebraically. Makes me so happy. How do we find the intercepts of any kind of function? Oh my god, it's quadratic. How many ways are there to solve a quadratic?
A couple trillion and
What are the 5 ways to solve a quadratic? Factoring, square root, complete the square, quadratic formula,
good old square root.
graphing calculator. Square root, complete the square, quadratic formula, factoring, graphing calculator. Which would you like to use besides graphing calculator? The Gunter-Guess method? No, not loving it. Not loving it.
I'd say square rooting.
I would square root as well because the factoring here is going to be nasty with the negative 2.
And x squared and 9 are both perfect.
Correct. So first thing I'm going to do is take the 9 over to the other side, so it becomes negative 9.
Uh-oh.
What's uh-oh?
It's negative 9.
But it's okay.
Square root and negative.
But it's okay because what's going to happen with the negative 2? It's going to become positive, so we're okay with that.
That's good, because you can't square root a negative number.
How do I get rid of an x squared? And remember, what has to go in front of a square root? Plus or minus, because there's 2 x-intercepts, so I need both values. What do I do with this mess, with the fraction, with the plus and minus, with the roots? Yeah, if we can square root it, we do. If we can't, we just leave it. So can I square root 9? Can I square root 2?
No.
Do I need to rationalize?
Yes.
If you want to. You don't have to, but you can if you want to. I'm going to leave it. So it tells you this value right here is the negative 3 over root 2. See, you wouldn't have guessed that. And this guy has to be the positive 3 over root 2. How do I know the negative's on the left and the positive's on the right?
Because that's always how
Because the negative values and this is the positive values. Okay, how do I state this domain? Well, remember, what's the notation for between? Because that's what I need to say is between these 2 values. U is and.
K.
Less than or equal to x less than or equal to means between. And I need to put the lower value first
And the higher value second.
and the higher value second. So just making a note in case you forgot, this is mathematically for between.
Unlike the random U.
No U in this one, no onion. And then the range.
It's y is greater than or equal to because you can't square root a negative.
You're getting a little less robotic. I think you need to work on that one a little bit. How are we feeling so far?
Doesn't it have to be between 0 and
Totally screwed that up. Shoot. I got so excited to hear Andrew say it. But now we can't because it's between 0 and 3. Or 0 less than y less than equal to 3.
Well, it may be differently, but
Because I like variety. I like to show you all ways.
it may,
And because I don't use this one, I like the other one better.
it may be a different range, but you still
You can't square root a negative.
number.
Even now we're in
This is about as hard as they're going to get. Vertex. Oh, crap, we don't know. Why don't we know?
Because it's in this form. Remember
Yeah.
called
What do we need to do to it?
some
It's not quite called factoring. It's called,
factoring.
no, completing the square. That's what we want to do is we want to complete the square. The factor will only give you the x-intercepts. It's not going to give you the vertex. So that's why we want to complete the squares in order to get the width, the vertex, and the direction. Great time to review completing the square. Keep the first 2 terms. Push the last term off to the side. Then we need to fill in these two spaces. How do we fill in this space? Where does it come from? So we take the middle, we divide it by 2, and we square it. So b divided by 2 squared from last year. So it is 4. How do we get the number at the end?
On the opposite of what we did,
Why?
so that it remains equal.
Yeah, because to balance an equation, if we add a number, we have to subtract it.
And this is not the same completing the square that we use for solving fracts.
Yeah, no, it is. It's exactly the same. We take the first 3 and factor them into a perfect square trinomial, which is a binomial squared. X plus 2, where does the 2 come from? It's the square root or it's b divided by 2, so either way. So the b divided by 2 gave us that. Then we combine the last 2 numbers and just smush them together. Minus 2. So just to repeat, the reason I didn't factor is because factoring will only give us the x-intercepts. This will give us the direction, the width, and the vertex. That's why I chose to complete the square.
But it won't give us no x-intercepts.
We'll calculate them in a second.
Nice grammar, Sam.
Vertex.
Negative 2, negative 2.
Direction. Width. Step 1 of drawing the radical. I do a step before I go to 0. Yeah, ignore everything underneath. And again, you don't have to draw it, but just be aware everything underneath is gone.
Because
Oh, okay, yeah,
a negative number.
we got it. Now go to the x-axis, mark the intercepts. Go up to y equal to 1, mark the points. Double swoop or little hill? Why double swoop? Because it's an up parabola. So swoop to the left, swoop to the right. Domain. No, there's no guessing. There's no guessing. Okay, find the x-intercepts. How would you like to find the x-intercepts? The guess and check Gunther method? No.
Square rooting.
Okay, so if we go back to the original, you guys are saying, well, let's factor. The problem is, it's not factorable. So we need to go to one of our backup methods to solve a quadratic. What are the backup methods? Quadratic formula, completing the square,
Graphing calculator.
which is out, square root method. Your choice. We can quad formula this one, or we've already completed the square, which means we can work off of that one. I like to work off of this one. Arthur's like quad formula. Let's go. Okay, so 0 in for y. How do I get rid of the minus 2? Plus 2. Sorry for the interruption.
Instruction, we are now starting with our grade 10 students. Any grade 10 students last name beginning with the letter A through to the letter F. If you have not had your picture taken yet for this school year, or you wish to have picture retakes, if you could please make your way to the upper level in the gym. Thank you.
How do I get rid of a square? And what has to go in front of your square root?
Plus minus.
And that's the only way to get the two intercepts, otherwise you'll only have one. How do I get rid of the plus 2? And where do I put it with all this mess on the left? It goes in front. So minus 2 plus or minus root 2 equals x. So if you quad formulaed it, you'd have exactly the same at this point. Which one is the left intercept? Minus 2 minus root 2, because it has to be the most negative. And the other one has to be minus 2 plus root 2, because it has to be the lower, the least negative number.
Most negative.
The least negative. Okay, so domain. The domain's really the hardest part of these questions. Is it a union question or is it a between question?
It's an onion question.
It's a union question. So how do I say the left section of this graph?
Negative.
X has to be less than or equal to, and x has to be domain is the trickiest part.
Range is the easiest part. Because you're looking at the square root of a negative number.
How are we feeling so far? Show me a thumb. Getting it, kind of getting it, not getting it. Good. Last one we're going to do a cubic, because why not? Cubics are fun. How pretty that is. It's so pretty. Cubics come back in Unit 6, by the way. Okie doke.
Well, cross out everything that's in the negative.
Everything under, cross it out. You're going to go, and you little bump here are going to go.
Except for one thing. You can't prove a negative number.
Justine may lose it. I'm not responsible if she does. Okay, step 2.
X intercepts.
So I'm just going to split it into 2 halves. Just look at this little guy first. Double swoop or little tiny mountain? Mountain. Is it going to be exactly the same height? It has to be less. Why does the height have to be less? Because we have to square root it, and a square root of a number is always a smaller number. So I'm just,
Square root a cube.
this I'm going to use Gunther method, and I'm just going to estimate a tiny little hill in there. Like you can't even see it. It's so teeny tiny. You just want to make sure it's not bigger than the original and it's not equal to the original, because square rooting a number is always a smaller number. If it's 1, it would be identical. Yes, yes.
0.
It wouldn't exist then. Okay, now I'm just going to look at this half of the graph. Swoop or mountain? Got to be a little swoop. There's the cubic. Hardest part is the domain. So again, let's just look at the pieces. If I look at just the little mountain first. Between 1 and 0, and we don't have an equation, so we have to use Gunther method on this one. So how do I say between -1 and 0? -1 has to come first because it's the smaller. And then 0. How do I say the domain of the swoop?
Onion. X is greater than or equal to 1.
Agree? X is greater than or equal to 1. The range. Well, the little bump is going to be encompassed on this guy because the lowest is going to be 0. Please don't say it, Andrew. And the highest is infinity. So y has to be greater than or equal to 0. That was awesome. Questions?